So good morning. I'm getting this started. I actually am recording this time, so that's wonderful. It's so good that you guys are here. I hope you guys are doing well. We're going to be doing day 2 of 4.5. So, yep, you're going to have another assignment from 4.5 up on here. Today, we're really going to focus on given a graph, we're going to write an equation. So last time we focused on graphing given an equation. We're going to flip the script. We're going to be going the other way today. So to do this, we're just going to do a quick review of what we did last class. And then we're going to do a little activity where I'm going to show you guys an image. And then you guys are going to try writing down the equation. Ooh, so much fun, Mr. Kraft. Ooh. Yeah, I get that a lot. So I get it. I get it. So let's take a look. So let's just review really quickly. So let's review really quickly what we did last class. So last class we talked about the kind of standard format for a trigonometric equation or a sinusoidal equation. So we have y equals d plus a times sine of the quantity of bx minus c. But remember, this is only if b is 1, right? So this is if b equals 1. Okay. So so remember, if b doesn't equal 1, then we're going to have to factor that inside. And we talked about that last class, right? So b times the quantity of x minus c over b. Okay, so this is if b is not 1. Okay. Okay, we're doing okay, guys? So let's go ahead and define some of these things, right? So so just as a general reminder, remember if it's inside, it works backwards. If it's outside, it's just normal, okay? If you need to remind yourself of that, you could write it down. But remember, anything that happens inside a function is backwards. And that's true with anything, right? With any transformation, anything happening inside the function is going to be backwards compared to the outside, okay? So remember that your phase shift, right? That's left or right. That equals c over b, right? And remember, if b is 1, then it's just c, right? So if b is 1, then it's just c, right? So your phase shift left or right. Okay. D, so the midline, oops, midline is just, ooh, I should go like this, is just y equals d. Okay, if there is no d, remember there is a number that represents nothing, and that's 0. So the midline is always just y equals d. Okay, the period, right? Your period is always going to be your new period is going to equal your old period divided by b. And remember, it's divided by b because it's an inverse relationship, right? So this is multiply by b. So when we go to get our period, it's divide by b. And that's why I like to think of everything on the inside is backwards, right? So we take our old period divided by b. Now remember, for sine and cosine, what's the old period always going to be, right? It's always going to be 2 pi. So for sine, so maybe we just make a note of that, right? For sine and cosine, right? Old period is 2 pi. Okay, for sine and cosine, old period is always 2 pi. Okay. If I'm going too fast, or again, if you guys have any questions, please say something. You guys are being like zombies today. You know what I mean? Like, you guys could be totally braining out right now, and I wouldn't know because, well, I take that back. I would know if 2 of you were zombies. But everybody else is gonna, you know, it's gonna be the 3 of us, guys. We're gonna take them all on, okay? All right. So you guys are just like, Kraft, just keep going. All right, cool. I'm just trying to make class interesting. Amplitude, right? So what's amplitude? Amplitude is the distance from the midline to a max or min. Distance from midline to max or min, right? And it's that A value. So it's the sorry, my handwriting, I'm starting to look like a doctor here. So the distance from a midline is to the max or the min, that's your amplitude. Okay, you can go up or down. Technically, they define it as up, but, you know, who am I to keep all you pessimists down? All right. Yeah. All right. So, not related to math. All right, write an equation. Okay, so what we're going to do is we're just going to do an activity today where I'm going to show you photos and you're going to write the equation for this. So do you guys want me to review the difference in graphs between y and cosine really quickly? I'll do that really quickly before we get into this. All right, so here's a unit circle. Okay. And then, so remember, x is left to right, y is up and down. So if I took a look at, right, if we think of this as a Ferris wheel, right, so we get on at 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then, so if I graph sine of x, then sine starts at 0, it goes up, right? And the 1 has to do with the amplitude, so that's the radius, right? So amplitude on a circle is your radius. So that's kind of cool to think about, right? And then we have pi over 2, pi, 3 pi over 2, and 2 pi. So this is going to be 1 period. And we know at pi over 2, it's going to be 1. At pi, it's 0. At 3 pi over 2, it's -1. And at 2 pi, it's 0. And then I just put a nice sexy curve between all of them because curves are sexy and we want to be sexy in math, right? That's why everyone hates algebra. It's so not sexy, you know, because it's all those straight edges. Okay, so there's sine of x. And then if we want cosine of x, so again, the radius is still going to be 1. And then we're going to have pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so then, so it's the x. So I start out at my max radius, right? So I start out at my max radius. So I start out at 1. Pi over 2, I don't have any width. At pi, I'm at -1. At 3 pi over 2, I'm at 0 again. And at 2 pi, I'm at 1. So again, we get some curvature going on here. Okay, some concavity, if you guys want those fancy words. And then we got cosine of x. Okay, so with that said, we have our basics here. Nothing's really moved. So what we're going to do today is just kind of an activity together. I'm going to post a picture and then give you guys a set amount of time. And I want you to write the equation for the graph. Okay, does anybody have any questions or comments about what we're going to be doing? Like maybe you just want to go full teenager and be like, this is stupid, right? Because that would be very teenagery of you guys. And so that would be a normal response. But it's good to know, like I only know that 3 of you guys exist because only 3 of you have communicated either with your camera or through chat. So are you guys doing okay? Should I call the cops? Blink twice if you have a home invasion. Thank you for saying hi. I appreciate that. Good morning. Blink twice. All right. So you guys ready for this? So I'm going to give you a picture and you're going to practice doing that. Okay. So here is your first, just like, come on, Craft, get yourself out of there. Here's your first, do you guys need me on here? Do you need my picture? Here, I'll just make my picture smaller. There we go. Everyone's happy now. Hey, so take a second, and by a second, let's do we're not doing 5 minutes. That's way too long. Let's do 40 seconds. Okay, write an equation for that. I did 40 minutes, didn't I? Oh my gosh. All right, let's try this again. All right, so don't call SWAT on me. That's not a funny joke. Don't do that. All right, so let's take a look at this one. So when doing these, you always want, remember, we're lazy, right? And we want the answer in the fastest way possible. So you always look for the easiest solutions first, because if it's easy, then you're done, right? So always look for the easiest solutions first. So the easiest solution first is going to be one that looks like cosine. So, or sine. So that's what I always look for here is I'm going to look at, right, the starting, the y-axis. So I'm going to look here, and I notice that I start, right, at a max, right? So this is a max. Ooh, look at my handwriting. Okay, so if that's a max, what function starts at a max? Cool. Great feedback. Yeah, look at you guys. Woo! Yeah, it's cosine. So I'm going to start with cosine on this bad boy. Now, let's take a look at the cosine. So for the next thing I'm going to do is I'm going to look at the period. So if I look at the period, I go from 0, and the next time, right, we call this peak to peak, right? So I'm going peak to peak. The next place I'm at is at 2 pi. So has the period changed? Nope, no period change. Okay, then the next thing I want to look at is there's no phase shift because I started, right? I'm not moved left or right. So the center line, it looks like I go from, oops, I have to erase this because I can't see. It looks like I go from 2 to 4. So half of that is 1. So my amplitude hasn't changed either. So I need to find my center line, and my center line is going to be this. You guys impressed with my straight lines? I too can hold down shift and click a mouse. So it's pretty neat there. Okay, so and then just, right, so my amplitude going up, right? My amplitude is 1 because this is 3, right? So if I'm looking at this, this is just a basic cosine of x. The only thing that changed here is I'm shifted up 3. Or you could do 3 plus cosine of x, not a big deal. Okay? So if you wrote this, winner, winner, I will think highly of you for the next 3 minutes. That is your prize. Okay, but at 3 minutes, it's back to thinking that you're nothing. Hey! All right. Not that I ever think that. All right, so cool. Do you guys get how this works? And you guys can ask questions if you need. We're okay? All right. So I'm going to go ahead here, and I'm going to load the next image. And we're just gonna do this. This is our game today. All right. Ooh, I'm going to have to move my image here. There we go. All right, so I'm gonna reset the clock. I'm gonna give you guys 40 seconds to try to get, as these get more difficult, I'll give you more time. But maybe that's a hint. Not, these aren't as difficult. We're gonna get to really difficult here at the end. All right, now I do now remember when I say find the equation for this, I want you guys to know there's an infinite amount of solutions, right? Like I just really want to be clear on that. So again, we're just going for the easiest, right? So because remember, like the last answer we wrote, we said cosine, but cosine is just sine shifted 90 degrees, right? So we could have written it in terms of sine, right? So again, we're just looking for easy answers. So the first thing I always look at is it shifted? Because if there's a phase shift, that changes everything, okay? And I really do always start with the phase shift. So here, if we look at this, it looks like if I go up 1, I go down 1, right? So it looks like this is my center line. Okay, so what starts at 0? Right, what starts on what starts on the midline? Sine does, right? So I'm going to do sine on this one just because it's easy. That doesn't mean I can't do cosine, okay? The next thing I'm going to look at is I'm going to look up here. I start at 0, and then I'm going to go peak to peak. So here, well, I'm going midline to midline. So here to here, I get to the same spot, right? Do you guys see how I get to the same spot from here to here? Okay, so the period hasn't changed either. So there's no period change. There's no phase change. The amplitude is still 1. Okay, so really, isn't this thing just shifted down, right? So I would write this as sine of x. You know what? X is so boring. Ah, that's not what I meant to do. It's not what I meant to do. Okay, there we go. So sine of x is so boring. Let's do sine of theta. Ooh, terrible theta. And then minus 4. How are we doing? Are you guys doing okay? Do you have any questions? Remember, this isn't a YouTube video yet. So you guys can interact with me if you want, okay? All right, cool. So again, starting off super basic, right? I just feel like last class we didn't do a lot of midline stuff, so I'm kind of making up for it now, okay? But we're doing okay. You guys are doing okay? Too bad we don't have anyone in here named Annie, because then I could be like, Annie, are you okay? Are you okay, Annie? You've been hit by some smooth precalculus. No? Okay. All right, you guys. I'm hip, right? I'm cool. All right. So we're going to increase the difficulty just a little bit, but I still think you guys are going to be able to get it in the same amount of time. Okay? So 40 seconds for this one. Oh, this is wait, stop. I kind of made this impossible. Wait. I got to stop this. Do you guys see where I made the mistake? I put the oh my gosh. Green snake. I put the y-axis in radians. So, that makes it difficult. Okay. So, I'll give you guys a hint. The amplitude hasn't changed. Does that help you? The amplitude is 1. Okay. So, the amplitude is 1. I apologize. Here, I'm going to put this back up. The amplitude is 1. Okay? The amplitude is 1. Ooh, I really like that answer, by the way. I am going to ask, though, if you guys do share your answers in chat, that you make it a direct message until the timer's up. Does that make sense? Because a lot of people are going to look at that answer and be like, oh, yeah, that's the answer. No, there's lots of different answers for this. So I'm going to go over all of the different answers for this. So with this answer, you were like, okay, so Krep tells me that the center line, the midline, and the amplitude haven't changed. So it looks like I start at a minimum and I end at a minimum at 2 pi, so the period's not off, right? So totally negative cosine of x would be an answer, but that's not the only answer. Another way we can do this is think back, well, the period's not off. Well, cosine, normal cosine would start here. So isn't this just cosine? I wanted to do theta. Can we make that a theta? Okay. Cosine of theta, and then I can go minus pi. Right? Isn't that just cosine shifted to the right pi? Do you guys see how it's just shifted to the right pi? If we go like that. Okay. So now that I showed that to you, there's some really cool hidden gems here. These two are equivalent. Isn't that cool? Do you guys see how these two are equivalent? That's pretty cool, right? That's a property I don't have to teach you. Like, they're equivalent. Okay. Also, sorry, I'm getting kind of messy here. Also, we could do the same thing with sine. So you might notice that sine would start right here, right? Notice how that's halfway between 0 and pi. So then if sine starts at 0 and then goes up and comes back down, right? So peak to peak would be right here. So we could say sine sim. Oh my God, I'm embarrassed for myself. Don't look. It's going away. There we go. Sine of theta minus, right, pi over 2. And that should make sense because I also said it could be cosine of theta minus pi, because sine and cosine are off by a factor of pi over 2, right? So that's kind of cool, right? And then we could also go the other way, right? So I could say sine of theta plus pi over 2. You guys see how that it's over here as well? So again, do you guys see how many different ways there is to write this equation? There's lots of different ways, okay? Lots of different ways. Are we doing okay with that? How do you guys feel about that? Okay. Is this confusing? 3 out of 3, let's go. Yeah, all 4 are equivalent. Isn't that crazy? Right? So we have to remember that there's a lot of overlap, right? And one big thing that we do with trig is, like systems of equations. So one thing that you guys, if you keep going on in math, is you'll learn about Taylor series. And any wave, now this is going to blow your mind, any wave, like literally any wave in the universe can be made up by a finite sum of sine and cosine, or just sine waves, because cosine's really just a sine wave, right? So any wave in the universe can be written as a combination of a finite amount of sine waves. So that's really cool, and that's called a Taylor series. And you guys can learn about that if you keep going in math. It's really cool. Okay. So what's important, right? If you guys haven't done really too much with systems of equations, but there's a whole branch of math called linear algebra, and it deals with stuff like that. And the thing is, you can't have a system of equations with duplicates. So you need to be able to identify duplicates. And linear algebra has a really cool way of eliminating duplicates called row echelon reduction. But we don't need to go there. Let's keep going. Kraft, you're talking too much. All right. I just want to get you guys excited about math. Let's skip around. Here we go. Okay, now we're starting to change things, huh? Okay. So I'm going to give you guys a little bit of time. The graphs on this one are okay. So I'm going to give you guys 40 seconds to try and figure out this one. All right. So, gosh, I lost track of my timer on this one. What time is it? 11:44, and we're out at 12:10, right? Okay. All right. So, can you guys? You guys are smart, so I don't need to baby walk you guys through this. What's going on here? What kind of transformation is going on here? Yeah, I agree. I'm pretty amped up too. You know what I'm saying? Like, yeah. You know what I mean? Like, go to the store. And, so what this function did is it went to the store and it bought some amp energy drink, and it drank how many of them? It looked like it drank 4 amp energy drinks, right? So I'm trying to see, math is real life. And the next time you see a kid at the corner store buying some amp, be like, oh yeah, I totally see that you're multiplying your amplitude there. And that's how you get friends, because the person that looks to you and that says, heck yeah, I am, then you know that they're a cool person. And if they laugh at you, they probably aren't worth your time. It's a good litmus test. All right. Kraft is weird, so let's just keep going. I might be losing my mind. What did you guys use, sine or cosine? Yeah, cosine, because it starts at a max, right? So I would say I have cosine. Oh my gosh, that looks like a 5. That's an S. And then I'm going to put a 4 in front of this, right? And then nothing else is happening, so I'm just going to say 4 cosine of theta. And again, there's lots of other ways to write this, but that's just the easiest, right? And we want to tend to the easiest, right? Not only is that a mathematician thing, it's just a physics thing, right? In life, we will always tend to the easiest path. That's why water always goes, right, the easiest path down, etc. Okay, let's do some more. I'm so excited. Okay, those are boring. Let's do these ones are exciting. Didn't mean to do that. Okay, let's reset the timer. Let's give you 40 seconds for this, and then we'll get to the hard ones. That was my polite beeper. Hey guys, this one was a bit harder, wasn't it? Because you can't just look at it. You're gonna have to do a little arithmetic, huh? So, to help people out, what did you guys start with? Sine or cosine? Okay. And I would also start with sine because if we look here, it starts at 0. Right? It starts at our midline, right? It starts at our midline. So if it's starting here at our midline, so if I'm looking at sine, because I saw the sign, it opened up my eyes, I saw the sign. I don't know the rest of the lyrics because it doesn't have anything to do with math. All right, so I want to see when it repeats. So it looks like it repeats right here. Looks like it repeats right here, right? So how many times does it repeat between 0 and pi? 3 times. Okay, but I could keep going. 4. And then, sorry, 4 times. Sorry. 1, 2, 3, 4. Right, I can count. 1, 2, 3, 4. So what would normally be a period of 2 pi, now it happens 4 times, right? So right? What are we doing here? So is my b going to be 4 or is it going to be 1/4? Right? Are we squishing in like an accordion or are we stretching out, right? Are we squishing in or stretching out? So to do this, we have to figure out, now we have to remember, and this is the tricky part, is that we have to remember that what we write on the inside is backwards. So I'm going to write 4 theta. Because what's really happening is my new period, or as I like to say, the noop. That's actually not what I like to say, but I'm going to make it something now. The noop, the new p, right, is our old p, right, and then divided by b. So it's my old period divided by 4, right, my new period. It's 1/4 the original. So when I write it inside, it's going to be backwards. Oh, can I spell backwards? Back. Okay, I'm done. I'm not going to do it. I'm not going to write it out. The handwriting's too bad. Okay, so it's inside, it's going to be backwards. Okay, so this, you can think of it as taking up my old period 2 pi and dividing it by 4. So it's going to be backwards. So that was a bit trickier, wasn't it? Like, do I write 1/4 there or 4? Yeah, it is tricky. So it happens 4 times as many times. You can think of it that way, if that helps you out. All right, are you guys ready for the truly hard ones? This was all warm up. So I'm going to increase the amount of time, and then we're going to, so all of these have only had one type of transformation. So now we're going to get into composite transformation. So remember, composite means 2 or more. Okay, so I'm going to increase the amount of time. I'm going to do 1:30, and let's do this. I gotta load a picture. So I got 3. Okay, so here's our first one. You guys ready? Here we go. Okay, and we'll start our time. Do I need to zoom in? All right. Now, those of you stressed out by the timer, this is great practice for AP Calc. Now, it's great practice in the sense in AP Calc, you'd want to take 2 minutes or less per multiple choice question. And this would be a multiple choice question on the AP Calc test. So all my homies who are planning on taking AP Calc, this is great practice. Okay. So, well, a question like this wouldn't show up on the AP Calc because it's a little basic. But you would probably get the equation of this and then graph the derivative. That's probably what you would do. So what were we going to do here? Well, the first thing I look at is it doesn't start at a max or a min, and it doesn't start at 0. So right off the bat, I know that it's going to have a phase shift. So I just take a mental note of that. It's a phase shift. Now, when you have a phase shift, you have options. You can either pick cosine or sine, right? Whatever's closest. So because if I look right here, because that's not labeled, I'm inclined to go with sine and go with pi over 3. Does that make sense, guys? Okay, so I'm going to go with sine. Okay, so, and then here I zoomed, and so I'm going to have to zoom out just a little bit. So then I'm going to have to figure out where a full period is. So a full period is where it's going to happen again. It doesn't look like that's a great place to start with the full period. So if I go like this, it looks like that is my full period from there to there. Do you guys see that? That's one period. Okay. So just really quickly, so if I combine those, so negative 5 pi over 3, and then I should go like this, minus negative 5 pi over 3, right? So I'm getting my total distance. So I'm taking the end minus the start. I hope this is making a sense, right? So so that's 6 pi over 3. So that's 2 pi. Okay, so my period is the same, isn't it? So my period is the same. I just did all that to show that my period hasn't changed. Okay, my period hasn't changed, so I have the same period. It looks like my center. It looks like my center had my midline. Sorry, I always call it a center line. The midline hasn't changed. Okay, so I'm not shifted up or down, but it does look like if you take a look here, that's exactly halfway between 0 and 1, right? So if it's exactly, so that's going to be 1/2, and then this is going to be negative 1/2. Okay, so my amplitude has changed, right? So my A is going to equal 1/2, right? My period hasn't changed, and then I think that's it. I didn't move up or down. So then how far did I shift? I shifted pi over 3. So my C over B is negative pi, or sorry, let's call it positive, pi over 3. So then my equation is going to be 1/2 sine of theta minus pi over 3. Are there any questions about that? You could have done the same thing with cosine, but cosine is just a little bit harder because then you just have to figure out that this is pi over 6. Okay, so if you wanted cosine, it would be 1/2 cosine theta plus pi over 6. Because negative pi over 6 is exactly pi over 2 away from positive pi over 3. Pretty cool math, huh? You guys are stunned. All right, you guys look okay. So 1/2. So you did 7 pi over 6. Yeah, you could do that. You could do that as well. You can do that as well. So again, there's going to be infinite answers there. Again, I'm always going to go with the easiest one if possible. Are we doing okay? Are people finding this worthwhile? Are we doing like is anybody like drowning slowly by yourself and you guys need help or? Okay. We're going to do another one of these. So I'll reset my timer. Okay, so here's the next one. Okay, so I'm going to give you guys 1:30. So I'm not going to lie, I'm looking at the answer that I wrote for this, and I would totally not have gotten that answer this time around. So just remember, as I go over this, there's more than one answer. And if you guys want to share your answer and you want me to check it, I can go ahead and do that. But in this case, yeah, let's check this out. So there's a lot going on. So I'll check your answer in just a second. So so first thing I'm gonna look at is there's a shift. Okay, so we know there's a shift. There's an amplitude change. So the amplitude change is really easy. We're going up 3, and we're going down 3. So the center line doesn't change. The amplitude is 3. So where am I going to write this? My A equals 3 for sure. Right? My D equals 0. Okay. And then, so now what we need to do is look at the period. So the easiest way to look at a period is this. Oh gosh, crap. The easiest way to look at a period is this. Come on. Is this. Third time's a charm. Okay. So this is 3 pi over 2. Negative 5 pi over 2, so I go 3 pi over 2 minus negative 5 pi over 2. So 3 plus 5 is 6, 7, 8. And yes, I used my fingers. 8 pi over 2. So that's my new period. Or as I coined today, the noop. Okay, so the noop is 8 pi over 2. Okay, so then we just have to remember that means that 8 pi over 2 equals my old one over b. So we can go ahead and solve for b, right? So let's see here. I'm going to be dividing by 8 pi, so the pi's are going to cancel out. So that's 1/4. Sorry, so b is going to equal, so we're going to have 1/4 and then times 2, so that's 1/2. Just keeping track of everything over here. Do you guys see how I set this up? Does anybody have questions about that? Right, this is my noop. And then it's old over b, right? I'm using that function there. I'm making noop a thing, so you guys can't fight that. That's gonna happen. I'm making it a thing. Okay, so I get b equals 1/2. And then at this point, I just have to figure out, am I gonna use cosine or sine? And then what phase shift I'm gonna use. Now, I'm gonna use a phase shift. Oh my gosh, Kraft. Figure out your stupid streaming capabilities. I'm gonna start here, because I think that's easy, okay? So if I do that, it starts at a max, so I'm going to use cosine. So I'm going to say I have 3, okay? That's my amplitude, and then cosine, and then parentheses. Now my b isn't 1, so I'm going to factor that out. So I'm going to have double parentheses here, and then I'm going to have theta, and then I'm going to have plus 5 pi over 2. So this is that's my immediate answer. Now there's lots of different answers. So the answer that I had gotten when I wrote these lesson plans was I did a reflection. So I started down here and did a reflection. So I used cosine, but then I did -3. Does that make sense? So another way you could do this is I could have said -3 cosine, and then 1/2, and then theta, and then minus pi over 2. No, plus pi over 2. So that's another way that you could have written it. That's how I did mine the first time. Okay. The person who sent me your answer would be incorrect because you didn't. Oh no, you're right. You would factor out the 1/2. I see what you did. Is that what you did? No. Your answer would be incorrect. Sorry, I'm just. You can use extra theta. It doesn't matter. I mean, technically it is theta because we're in radians. So if you're in radians, it's not x, it's theta because radian's an angle. So by technicality, it should be a theta. It should be an angle. But you can define x as being as an angle, right? So that doesn't make it wrong. So does that make sense that the person who I'm talking to, right? You said you didn't have the extra parentheses in there, so it would have been incorrect, right? So you guys see how I have the extra parentheses here? I'll highlight those, right? These extra parentheses. Okay. Does anybody else want me to check their answers real quick? Are you guys? Is this when you guys don't give me feedback? Is this helpful? Are we doing okay? Like, I want to help you guys, and when you guys don't give me feedback, I don't know if I'm helping or if you guys are just more lost. Okay, so taking a look, so your question, so taking a look at this top one, right? If I didn't have it factored out, so what happens if I didn't have it factored out? This is what it would look like. So if I didn't have that factored out, it would be 3 cosine of 1/2 theta. And then I'd take half of that. So then it would be plus 5 pi over 4. Right? Do you see? So when I pulled out that 1/2, it makes it so that it looks exactly how it is on the graph, right? But if you don't factor it out, then this is 5 pi over 4, right? Because remember, our phase shift is C divided by B. And so if B isn't 1, then you have to factor it out to have this be there. So you can write it either way. Does that help out with your question? And you said a direct message, so I won't want to say your name. Did that help you out? Okay. Right? So both of these, again, so the green and the red are correct. It's just I always prefer, now if you had Mr. Race prefers this way. Right? And that's Mr. Race. But I'm Mr. Kraft, and I've always preferred doing it the green way. Both are correct. You would never get marked down wrong for that, right? And Mr. Race wouldn't mark you down either. We both accept both of those answers. So some of you I know are coming from Mr. Race, and Mr. Race does teach it more the red way. I like to teach it the green way because then when I'm really stressed, I'm just pulling numbers off the graph, and I'm not trying to convert them right here. Does that help out? Okay. Both are correct. All right. And Mr. Race is a jerk. No, I'm just joking. Seriously, though. He might be a jerk. All right. Well, we only have 3 minutes left. So with that said, I feel like I could force another problem in, but we're just not going to have enough time to do it. Do you guys want to do one more? Okay. The two people with cameras on just shook their heads no. So I'm going to take their word for it. So with that said, the homework it's going to be posted at the end of class on WebAssign. So in a couple of minutes it'll show up on WebAssign for you. Make sure you guys do that, get that done. I'll be updating Skyward today. And just remember, I have office hours in the morning because I coach in the evening. So that means tomorrow and Thursday morning I am available. If you guys come and join, we can do work together. I don't want you guys to be confused or lost. We can do this together, okay? We're in this together.